And welcome back, students. As we get into our next lesson in polymorphism, we're going to discuss today downcasting and upcasting. So getting started, consider the following legal code. Sale variable, discount variable equals new discount sale, paint 15, 10. Sale variable equals discount variable, system out line, sale variable dot toString. Well, an object of a derived class, in this case the derived class is discount sale, also has the type of its base class, in this case sale, and can be assigned to a variable of the base class type. So let's consider the invocation of the method toString on the last line of the preceding code. Because Java uses late binding, the invocation sale variable dot toString uses the definition of the method toString given in the class discount sale. So the output is paint price equals 15.0, discount equals 10.0%, total cost equals 13.5. Because of late binding, the meaning of the method toString is determined by the object, not the type of the variable, sale variable. Now, you may wonder why, or you may ask why, you'd ever want to assign an object of type discount sale to a variable of type sale. Now, you can make such assignments more often than you might think, but you tend not to notice them because they often happen behind the scenes. Java does them automatically, and you have all sorts of things happening that you don't explicitly do. They're all implicit. Now recall, for example, that a parameter is really a local variable. So every time you use an argument of type discount sale for a parameter of type sale, you are actually assigning an object of type discount sale to a variable of type sale. So for example, consider the following invocation. Take the definition of the copy constructor for discount sale. Super original object. In this invocation, original object is of type discount sale, but super is a copy constructor for the base class sale. Therefore, super has a parameter of type sale, which is a local variable of type sale that is set equal to the argument original object of type discount sale. Now, note that the type of the variable naming an object determines which method names can be used in an invocation with that calling object. However, the object itself always determines the meaning of a method invocation performed by an object. This, of course, is what we mean by late binding. The type of a class variable determines which method names can be used with the variable, but the object named by the variable determines which method of the name is used. There is a special case rule, and the special case rule is pretty much the following. The type of a class parameter determines which method names can be used with the parameter, but the argument determines which definition of the method name is used. So it's very important there to note that when we start talking about these, you notice it says, but the argument determines. Right, so let's remember, on arguments, what you pass in the parameter. So because remember, you can have, for example, if we think back even to programming one, where you can have multiple constructors with similar parameters, and what you put in those parameters determines which method you're actually using. Assigning an object of a derived class to a variable of a base class or any ancestor class is often called upcasting because it is like a typecast to the type of the base class. In an inheritance diagram, therefore, base classes are often drawn above derived classes, and we've seen this before. You put the base class at the top, derived classes underneath. So for example, sale would be at the top, discount sale would be branched off underneath it, same thing with any other type of sales. Now, when you do a typecast from a base class to that of a derived class, or any ancestor to a descendant, it is called a downcast because you can think you're moving down the flow chart rather than moving back up. An upcast would be going from the derived to the base, downcast is going from the base to the derived. Now, upcasting obviously is very straightforward. You're moving from the derived class up to the first class, and we've seen that example with the super call. There's really nothing kind of funny to really worry about with it, and in Java things pretty much always work out the way we want them to. Downcasting though, when we want to move from that base class down to the derived class, that's a little bit more troublesome. So for example, let's look at this. We have sale variable equals new sale, paint 15, discount variable equals discount sale variable. It's going to throw an error, right? Because we're trying to notice this a typecasting going on right here. The downcast in this example does not make sense because the object named by sale variable has no instance variable named discount, and so therefore cannot be an object of type discount. Because remember, discount sale has additional instance variables that sale does not. Now, this is because every discount sale is technically a sale, but not every sale is technically a discount sale, as shown by this example. So it is ultimately your responsibility as the programmer to really only use downcasting in situations where it makes sense. If it doesn't make sense, or you're going to have errors thrown like this, you should avoid it. Now, it is instructive to note that discount variable equals discount sale variable will produce a runtime error, but it's going to compile with no error. This is very important. So if you run, put your code in there, it's going to compile fine. However, you can actually hit run. That's where you run into the issues, because technically it's not looking for those instance variables yet. However, if we do something like the following, which is also technically illegal, now we will get a compile time error. So discount variable equals sale variable. Now, Java catches these downcasting errors pretty much as soon as it can, which may be at compile time or at runtime, depending on the case. Sometimes if you're using an IDE, they have on-the-fly compiling, they'll catch that stuff a little quicker. So it just kind of depends on what you're doing. But you should note that one is a runtime error, one is a compile time error. Now, although downcasting can obviously be kind of dangerous because of the potential errors and stuff like that, it is sometimes necessary. For example, we inevitably use downcasting when we define an equals method for a class. So, for example, note the following line from the definition of equals within the class sale. Sale of the sale equals sale other object. This is a downcast from the type object to the type sale. So we actually do use downcasting sometimes. The equals method is one of them. Without this downcast, the instance variables name and price in the return statement reproduced as follows would be illegal because the class object has no such instance variables. It doesn't know what name and price are, but sale does. So then we say return name.equals other sale.name and price equals other sale.price. It can actually compare those because we downcasted. Upcasting, not an option. Now, obviously, we're talking about downcasting, so naturally we should talk about some pitfalls with it. Now, as I mentioned, it is the responsibility of the programmer to use downcasting only in situations where it makes sense. The compiler makes no checks pretty much to see if downcasting is reasonable. The compiler doesn't know. Remember, a computer is stupid. It's only as smart as the person using it. So if you want that program to be smart, you have to use smart programming and only apply those downcasting in situations necessary. Now, that doesn't mean that you should call yourself stupid and you don't understand this. It just means you have to be self-aware of situations. So, however, this is a quick however situation. If you use downcasting in a situation that does not make sense, you're usually going to get a runtime error message. So if you say, well, I don't know because I'm just confused by the whole downcasting thing. I don't know if I've done this correctly. I don't know if I did a smart programming technique or not. Well, here's a good way to find out. If you're using it in a way that doesn't make sense, most often you're not going to see it in compile time, but you will get typically a runtime error message. So here's a quick tip for you. All right, checking to see whether downcasting is legitimate. So hey, let's give you a tip here to try and make that smart programming a lot easier. So you can use the instance of operator pretty much to test whether or not downcasting is sensible. Now, downcasting to a specific type is reasonable if the object being cast is an instance for the type, which is exactly what the instance of operator tests for. Now, the instance of operator checks whether an object is the type given as its second argument. The syntax object instance of class name returns true if the object is of type class name. Otherwise, it's going to return false. So, for example, let's look at the following, which will return true if some object is of type discount sale. So, some object instance of discount sale. So, what you're saying is you have an object, it could be called sale 300, for example. You're going to say sale 300 instance of discount sale. It's going to check to see whether sale 300 is an instance of discount sale. If it is, for example, only a member of sale, obviously it's not a member of discount sale. Now, this is important because if you know that every object of every descendant class of discount sale is technically also of type discount sale. So if you had a descendant class of discount sales, so let's say you have one called like super discount. Well, if you have a super discount, that's still technically a discount. Right? Therefore, that expression is going to return true if some object is an instance of any descendant class of discount sale. Again, if some object was a member of sale, that wouldn't work because sale is a ascendant class. It is a base class, whereas descendant is a derived class. But if you have derived class, or if you have the discount sale, which is a derived class, and any classes that are below that of discount sale, this is going to work. So let's say you want to typecast to discount sale, then you can make the cast safer as follows. Discount sale ds equals new discount sale. If some object instance of discount sale, ds equals discount sale, some object, system out print line, ds was changed to some object. Else system print line, ds was not changed. So some object might be, for example, a variable of type sale or of type object. And that's going to wrap it up for today, folks. So we will see you next time.